right, welcome to the final frontier, the last talk, machine learning. There's going to be a panel afterwards. It's going to be very good. It'll have Herman, myself, and Alvaro, and maybe a bonus person I haven't been told. So today I'm just going to give you a little bit of a look under the hood of machine learning. So kind of like I'm opening the hood of a car. So you'll see the engine. You won't quite know how it works, but you'll get to look at it. I'll talk about like input and output data just a little bit. It's not going to be super technical, no exam or anything. But first we actually have a video from some of our machine learning experts in Miami that we're going to play for you right now. There should be some audio.
With dogs, like as an example. So I work at a dog shelter with a bunch of other people, and we have 1,000 dogs. And I train a lot of dogs, and if one of the dogs that I train gets a bunch of treats, I should take him out to the real world so he can help blind people. But if another dog is not as good as that dog and gets only a few treats, he should try again and keep trying until he can go to the real world to help blind people, because he wouldn't know where to go. So like if I get like a dog that's good but like bad, I should help him so he can go to the real world to help blind people. But like other people, they don't so like if I have another dog that like doesn't work the same as that dog, he should keep trying until he can go to the real world to help blind people. But like other dogs, if they can do better than him, like get 100 treats, they can help blind people so I can take them to the real world. Because they don't have to keep trying, because they already know everything.
Completely clear now, right? So let's see if we can improve upon that just a little bit. So in this talk, I'm just going to go over some graphs that are fun to look at for the algorithms when they're running. These are really basic algorithms. Then after that, we're going to just click through and run some code. I'm not going to live code up here because things always break when you live code. But I'm going to compress an image 1,000,000 times in size. I'm going to make it 1,000,000 times smaller using machine learning. And then after that, I'm going to cover some other applications, some production applications in addition. So I'm Michael Wise. I previously worked in chemical instrumentation. I got to play with liquid nitrogen and liquid helium a lot, which was fun. And I did some things in physics. One of the co-founders of Adobe used some software that I helped write, which was really cool. So since then, I've moved into data science. It's been really nice going into the cloud because building everything on the back end from scratch and maintaining hardware and servers is really no fun. Talents are better spent elsewhere. So the agility and the power of the cloud is a huge advantage that I've really loved. So what is machine learning really? So before machine learning, we just have conditional statements. We have programming, traditional programming. So if we have this input, give this output. If A happens, then do B. And this isn't a bad thing. This is a necessary thing in computing. This is part of programming, and it's going to stay around for a long time. So we'll continue utilizing that. But what if we have like a complicated situation such as driving a car? So like we have Teslas finally, we have Waymo. Self-driving is finally becoming a thing, and that's because we needed all this computational power to do the machine learning. So imagine you're in a car and you want to make a left-hand turn. There's a lot of input streams coming at you, and you have to integrate all those things together at the same time. So is there anybody coming? Are there multiple people coming towards you? How quickly are they moving? Are you moving? Are you allowed to turn left right here? Are there bicycles in the way? Is it wet? So as a programmer, if you want to program all those conditions and take into account 500 or 1,000 or all these possible things at the same time, impossible. Humans are not intellectually up to the task of doing that. So that's where we just record lots of data and we do machine learning on that data. So this is the simplest machine learning that you can find. This is a standard linear regression problem with one input and one output. So on the right, you see a bunch of data points. So imagine those data points come from an Excel spreadsheet. So you have the square footage of a house. Maybe this is a real estate example. You have the square footage of the house, and you have the price of the house. You just have a really long spreadsheet. You plot all those data points. Each row is a data point. So nowadays, we'll just code an algorithm that will explore a bunch of different lines, and it will try to find the optimal line that fits all of that data. So this is really like the engine behind all of machine learning, like variations on this technique. So once it finds the best fit line, we've done all that work just to find two numbers. We found the slope of the line and the intercept of the line. I don't want to give you high school nightmares or anything, so I'll stop the math there. But those two numbers give us that line, and now that model, that line is technically our machine learning model that we can use. We can give it a square footage, and we can predict the price of a house. So this is a super trivial example. Like, we would probably do this by hand, right? Like, if I showed you all these data points, you could just draw a line through it. So why do all that work? Well, computers can deal with 2 dimensions easily. So in this case, we have 2 input columns of data. We call these features in machine learning. So we have the square footage and the number of rooms. And the output, the thing that we want to predict, is the cost, which we call in machine learning, we call that the label. So these are terms that I want you to try to walk away with remembering today. You need input data, and generally you want to have something that you're trying to predict, the label. And this is like the limit of our human thought now, like 3D plot. If you try to go to 4D or something, it's just difficult to see. We can't imagine it. So we also have classification problems. So imagine, again, 2 dimensions of input. Maybe these are some like metrics for users on your website. And then your label, the thing you're trying to predict, is whether or not they're going to buy or not buy, whether they're going to convert or not. So the red ones that you see in the top right, those are users who did not convert. And the bottom left, all the blue ones, those are people who converted. So the purpose of this machine learning model, instead of trying to fit all of the data, is trying to find that boundary. So this is like a classification problem. It's called supervised because we already know all the labels. Okay, so this is where machine learning starts to get more interesting. You can do things that are unsupervised. So what if you don't know the labels? This is really useful for like segmentation. When somebody's signing up for some platform, maybe they're not going to say whether or not they're a hipster or a foodie or whatnot. Maybe you want to try to guess that for your whole customer base. So in that case, you take everything that you know about your customers, you run some dimensionality reduction, maybe you know 100 things about your customer, you reduce that down to 2 dimensions, and then you send out these little diamonds to go looking for a home. So if you look, you'll see the blue one, go look for a home in the top right. And they all kind of find a home. So notice the label is question mark. And after this algorithm runs, then we fill in the labels and we know our audiences. So machine learning is not magic. Things get stuck. That's why data scientists are in high demand right now, because you can't just go on Google and plug everything in and it works. As Herman was saying, like it still requires, no matter how much anybody says that you just plug it in and it works for their product, you're going to have to clean data. You're going to have to do interesting things to get it to work. So this one, all the dots on the top should be turning green, but it never gets there. But you end up with cool plots. So it's worth it. So now I'm going to click through and run some code. Okay, so at the top, we just import some libraries from code that people have written before, that Google uses, everybody uses. This is open source code you may have heard of before. Everybody in the world contributes to open source code. It's freely available. That's what runs the world of software, in case you haven't heard of that term or you're curious. Open source code is incredibly important. So we import an image, and this image consists of millions of different colors. So what I'm going to do is look at the color space, and I'm going to resample it with only 16 colors instead. So I check out the shape of the image, I flatten out the image, so instead of being 400 pixels wide and 600 pixels wide, 400 tall, I'm going to make it 250,000 pixels long, super straight image. Define a plotting function. Plot the color space. So these are all the colors that are being used. There's 2 plots because it's 3 dimensions, so don't worry about that too much. Run the machine learning clustering, which is super quick for this. This is a very efficient algorithm I just ran. So now there's only 16 colors in these plots. And finally, the punchline looks quite similar. So the image on the right is composed of only 16 colors, which is, I thought was pretty fascinating. This isn't a really efficient way of doing doing compression. So, but in the last year or so, there have been significant advancements in compression for files using machine learning. So Herman earlier talked about bananas a little bit. So this is something that Grupodot did. They did an actual production model for bananas, whether like low on stock, where the bananas are spoiling, where you're out of stock. This is an example that a Googler did at Google Next 2018 in like 2 hours. All they did was put a label at the bottom of the bowl that said, restock bananas, and they pointed a webcam at it, and they said like every 10 minutes, check to see if we're out of bananas. And all it does is send that picture into the Google Vision API, look for text. If it can't find any text, that means there's a banana in the way. So the reason I bring this up is because in business, you want to try to find hacky solutions to get something done very quickly. Okay, so after you get something done, then you try to improve upon it. But experiment, try to find a quick way to do something. So this is what the Google Vision API looks like. You can type in Google Vision API, and you can drag an image into it, and it will tell you everything about the image. It will tell you whether people are happy or sad. It will read all the text. So here's Watchdog. This is a company in Puerto Rico that does media observing. So say I'm company X, and I'm curious if WAPA is talking about me, or if they're talking about me on the radio, or I have a list of topics that I'm curious, is anybody mentioning them in the media? So I would call up Watchdog, and I'd say, hey, observe all these media channels for me, and let me know, send me reports on whenever somebody talks about me. So this is something that Watchdog's very good at, but it's very labor intensive. These guys, I feel bad for them. They were probably stressed out. I don't know. Like, I imagine that like maybe they have 2 headphones on, like different radio stations at the same time, like watching TV and reading newspaper all at the same time. So on top of listening for topics on all these different channels all day, they have to be able to recognize the list of topics from all the different clients that they have. They have to write a report, give their thoughts about it. They have to edit the clip down and send a copy of that clip over to the customer. And they have to be aware of a lot. So, they have to use the bathroom too at some point. So poor guys. So this is a ripe problem for machine learning. So speech to text has gotten very good. So we do all this on Google Cloud. Their speech to text is very good. So we automatically create transcripts of that. Automatically translate where necessary, so the agents don't have to do that anymore. Entity extraction, so once we have that transcript, we run natural language processing to go through and try to find all the topics that are important. So if somebody mentioned company X, if somebody mentions Trump, if somebody mentions big brown chairs, if a customer is asking for that for some reason. After that, we can do sentiment prediction on the sentences. So that eases up a little bit more work for the agents. And topic popularity, we send through Google Trends to see is this a really popular topic right now? Is it trending up and down once a month? Whatever. We also do machine vision on WAPA and other media channels to look for brands, identify faces, and also do speech to text for TV. So, semantic suite. Can you take over 2 seconds? I need water.
Okay. So, Semantic Suite es un producto que desarrollamos en la compañía. Básicamente lo que permite es hacer un monitoreo real de las conversaciones que están teniendo los clientes y en general la comunidad alrededor de mis marcas y alrededor de los mensajes. Entonces, un caso particular que nos gusta usar es, supongamos que soy una cadena de supermercados y el lema mío es que soy fresco y al mejor precio. Pero resulta que vamos a mirar y la gente dice, no está fresco y son los más caros. Es lo que la gente está hablando. Hasta ahí, digamos, no hay nada maravilloso en el análisis, simplemente estamos escuchando lo que está pasando en Facebook, lo que está pasando en Twitter, lo que está pasando en Instagram, lo que está pasando en web en general. Donde sí está la gracia es que nosotros incorporamos una manera de cómo hago yo para que la conversación se mueva de es caro y no está fresco a es fresco y al mejor precio. Entonces me da herramientas para saber cómo me puedo mover yo a través de la conversación. Es una herramienta para la agencia. A través de la conversación, cómo me puedo mover a dar el mensaje que yo quiero. Eso está cruzado además con una comparación. Ahorita Michael va a mostrar un poquito de eso. Yo compararme con mi competencia. Cómo me están viendo mis clientes, cómo me están viendo a mí y cómo están viendo mi competencia. Cuáles son los tópicos principales alrededor de los cuales hablan. Y adicionalmente desarrollamos un score propio para microinfluenciadores en Instagram. No sé acá en Puerto Rico si se mueva también, en Colombia se mueve mucho. Ya pocas marcas realmente están invirtiendo en estos supuestos grandes influenciadores, sino que están buscando grupos pequeños. Ahí siempre está la duda es con quién invertir, cuál realmente conviene. Y lo que hicimos fue desarrollar un score adicional que no solamente tiene en cuenta qué tantos likes tiene, sino realmente tiene en cuenta también el sentimiento de las conversaciones y los tópicos de los que hablan. Porque hay influenciadores que son muy famosos, pero cuando vas a ver no tienen nada que ver con la marca, simplemente generan escándalo, pero puede que eso no vaya en beneficio de lo que yo quiera y que el mensaje no esté alineado con lo que yo necesito que se esté hablando de mi marca o de mis marcas. Dale, muestra la show de tema.
I think I got it. Okay. So my Spanish is very bad. I hope I don't repeat anything that he just said. I'm working so hard on it. So I was joking with Alvaro that he should just leave me in Puerto Rico for like a month or two, and I'll be forced to learn. So this is part of Semantic Suite. We run this through sentiment analysis on Google's NLP. So we send in all the data, and it gives us back sentiment. So we can, over time, this is like 6 months of data for some banking that I ran a little while ago. We can see big events, positive or negative. We can see Bank of America, they have struggle with reputation. All big banks do. TD Bank, they're more neutral in reputation. And then we have Amaranth Bank, which is pretty cool. They're very low volume, so not as much interaction on social media, but they have very positive reputation. So they definitely have a lot of potential there. So this is another part of Semantic Suite. This is the top of tongue. So this classifies all the types of speech, the types of language, into subject, verb, and adjective. And once again, I'll use Amaranth as the guinea pig. So they kind of own this word happy, which was also interesting. Even the bigger banks have trouble having a high volume on happy. So this is a territory that they could build off of. So speaking of territory, we have latent Dirichlet allocation and LDA model. So this reduces thousands of dimensions down to just 2 dimensions. And you can hover over these different spaces and interpret what the natural language model is trying to tell you. So in this case, in the upper left-hand side of the plot where it says 1 and 5, this is kind of a negative place to be. So you have words like scam and fraudulent and gun and shaking my head and Florida. So place you want to avoid. I live in Miami, so it's okay to make the joke. And down at the bottom half of the plot, That's more of a happy area. Like there's some good words like thank and please in there. So the point of this type of natural language model is if you're a brand, you want to try to own a territory. You want to try to put a lot of positive words in that area. So you want to try to control the conversation that you're having with your customers. Whenever you're replying to somebody who's complaining on Twitter to you, they say, oh, blah, 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 bad experience, never banking with you again. So instead of replying to them and say, oh, I'm so sorry you had a bad experience, we need to fix this is terrible, you're kind of adding to the negative sentiment of the conversation. So if somebody's just scrolling through looking at over all these topics on social media for your brand, they're going to see a lot of negative words, and it kind of leaves an impact. So this is a situation where your agents instead could reply like, oh, we definitely want to make you happy, use more positive words in your dialogue with your customers. So the really cool thing about this is it gives you a metric to build your social media presence. It gives you a direction, which is kind of a hard thing to do on social media. It's very unstructured. It's hard for a team to keep track of what's going on social media in a structured way. So this is a cool product that came out of Columbia Grupodot recently. This is archetypes. So Carl Jung is a famous psychiatrist that kind of popularized the ideas of archetypes. So all of you marketing people in the room, which is probably a decent number, are aware of archetypes. So these are things like the hero and the innocent and the adventurer. These are personalities of people. So the type of speech that you have kind of indicates what kind of personality you are. So if you're using really daring words, then you might be an adventurer. I think I included a quote by Carl Jung. I like to include quotes. I am not what happened to me. I am what I choose to become. So we took millions of communications from all the top brands in the world, and we associated those with the personas of those brands, and we ran a machine learning model on them. So tons and tons of data. And what we ended up with was a machine learning model where we could feed in communication from Coca-Cola, for example, put it into the machine learning model and hit predict, and then it tells us what persona are they communicating to their guests, to their customers. So this is another thing that's kind of hard to do, like how do you quantify how you're communicating? So this is a good tool for that. It works pretty well. So finally, this is a sort of little bonus that Diego mentioned early in the day, that Grupodot recently was one of 20 companies in the world to receive the machine learning badge from Google. So a pretty big deal. They're the only Spanish-speaking Latin America country to have the badge. So how did we do that? So Google Vision that I was telling you about that you can look up and drag an image into and it will tell you everything about it, that's what you're looking at right here. So it tries to read all the text, and on the first line it does a decent job. It says Atlantic Telegraphy Company, so it kind of messes up already a little bit. Next line, instead of limited, it says Kudidid. And then if you go down to the paragraph, it thinks it's Chinese. So don't get me wrong, it does a pretty good job identifying text when things are good and it's clear. It even recognizes text that's not so clear pretty decently. But this one, there's no way. So Grupodot was challenged to come up with an improvement on that, to do OCR better than the Google Vision API could. So what do you think this says? Very difficult, right? Listen.
¿Qué creen que dice?
Pretty good. How about this one? This one I don't know, actually. Like I couldn't tell it, even after I looked at the answer. So we trained a very sophisticated model it takes the context of the word. So as humans, like if we can't read the whole word, if we can read part of it, we have a pretty good knowledge of the dictionary, we have a pretty good knowledge of what other words exist. So even if we can read half a word, we can kind of make it out. So that's where OCR models have kind of fallen short for a long time. So this machine learning model knows the dictionary very well, and we exploit that to read these really unreadable words. And it's amazing what this model has been able to do. I was looking at an example a couple days ago that was fed through it that was just black text and was able to find the answer. So this first one was Ardieres?
Ardieras.
Ardieres? Okay. So there's the answer right here where it says label. That's what the word actually is. Remember, that's like the thing we were trying to predict. And the Google Vision API, the distance is 8. That means that it got 8 letters wrong. So there's 1, 2, 3, 4, 5, 6, 7. It got all 8 letters wrong. Our model got it completely right. It got every single letter correctly. So this is a random sample from millions of tries. And it got most of them almost entirely correct. A couple of them it had difficulty with, like this long number. There's a decimal point somewhere you can kind of see in the middle. I think our model got an extra number in there somewhere. This was the unreadable one. Yobes?
Loables.
Loabes?
Loables. ¿No?
Okay. So, yeah, Google got that one completely wrong also. So this was going to be like kind of a punchline that we got the machine learning badge, but it was already mentioned earlier today. So that's my presentation. Any questions? Any at all?